All right, welcome to TRiRODS August 2025 somehow. We've got 3 talks today. The first is going to be by Yujun Ming. It's one of our interns this summer, and he took on a Java application written by somebody else and changing how its iRODS support was working. It's been stagnant for a little bit. So refactoring Cyberduck, migrating from Jargon to irods4j for its iRODS support. Take it away, Ming.
Hi, I'm Yujun Ming. I'm a student of UNC, and today we're talking about my projects that I do to refactoring the Cyberduck and especially its iRODS support.
And would you like to turn your camera on?
Oh, sorry.
Okay. There you go.
And at first, I will just introduce the Cyberduck and its iRODS support. For the current state, the Cyberduck is a library cloud storage browser for the Mac and Windows users, and it supports protocols like FTP, SFTP, and of course the iRODS. And in the Cyberduck, the users can browse iRODS storage like using a local file explorer, which is pretty easy and pretty straightforward. And the current integration of the iRODS is built on the Jargon library, which is iRODS legacy Java API. And currently, Cyberduck is maintaining their own Jargon library since the iRODS Jargon is already deprecated. So for this project, we are talking about how we change this situation. And here is the GUI of Cyberduck, so that we can see how we can open new connections here, and we can browse the folders, files, we can upload new files or download them by clicking those files, and we can see how the transfer goes. And I will also say, compare the Jargon and irods4j to see why we need to transform from the Jargon to irods4j. So at first is the code readability. That's in the Jargon is pretty complex and many hidden interval behaviors. Lots of things happens behind the scene. Where for the irods4j, it's pretty transparent. It's low-level API, pretty fundamental, which means we can have access to the full control of every activities. And of course, the control we control over Jargon is pretty limited, and many operations are auto-managed. And 4J control is pretty high. The developers can just directly control iRODS protocol behavior. We can decide what we want to do. And also, since the Jargon is already deprecated, it have limited support for the newer version of iRODS connections like iRODS 5, whereas the irods4j is fully compatible with iRODS 5 and beyond. And because of the code readability and these complicated codes, the Jargon is also harder to maintain, which is also the reason why Cyberduck maintains their own Jargon. Whereas for the irods4j, it's easier to test, debug, and evolve, which is, of course, a real good solution for the Cyberduck integration. And for the performance tuning, we see the Jargon is difficult due to the background behaviors of abstractions. And where the irods4j have turnable buffer size, chunking, streaming support, that I will introduce how we do that in the Cyberduck in following slides. And I will introduce this project by 3 parts. The first is replace Jargon with irods4j in Cyberduck, and how we enhance the maintainability, and also how we design the stream-based upload-download modules, and how the refactoring makes us to have more iRODS compatibility. So the first, as we can see the code from irods4j and Jargon, we can see how the difference these two APIs are. As in the irods4j is handled by the iRODS connection, whereas in the Jargon is handled by iRODS file system access objects. The iRODS connection is implements the Java autoclosable objects that make it more fundamental, easier to access, and easier for the everyone to understand when we are changing the code, we are refactoring. Where the iRODS file system access objects is implements the access object, which is also a part of Jargon. So it's everything is behind Jargon, which is difficult for people to understand. And as we can see, it's also have more different configurations. It's more complicated, whereas irods4j is pretty clear and pretty straightforward. That is why we think changing the Jargon to irods4j could also enhance the maintainability in this Cyberduck. that people can understand this code easier, extra. And the second part I do is design a stream-based upload-download module for the Cyberduck. As we can see, we cannot do the all this upload-download in a single thread, as that will cause a super slow speed, and it will also like not that efficient. What we do is we create a stream-based upload-download module that the file is divided into n chunks, and each chunk handled by a separate thread. The single thread will write and read or from a specific offset using the random access file. And under each single thread, it runs a loop and read or write fixed amount buffer each time. And all the operations will happen concurrently to increase the speed. And download have 3 times faster speed compared to the single thread downloading. As you can see, this downloading happens after I change it to the stream-based upload-download module. That's it have 1.6 megabytes per second. It's already pretty good under home Wi-Fi, and the server side is also not that fast. Before we change it to the multiple thread and we see fixed amount of buffer, it will take like 300 kilobytes, which is much slower. And of course, the new version of the irods4j will have more iRODS compatibility. We could handle the connection to different versions of server with the help of the more controllable APIs of irods4j. When running many features, we would like to detect versions from the connection first and see if it's in some range of the version, and we can decide the types of operation, which ensures the seamless compatibility without user configuration. And when it's a newer version of the iRODS connection, we can allow those modern features. We are also supporting the legacy environments of those older iRODS versions. And for these projects, currently it's already finished most of it. We have already finished writing the code, make the whole Cyberduck work, and we can connect to the iPlant, which is also server successfully. And all those functions work, upload, download, list, copy, delete, extra. And we also successfully implement the parallel upload download to speed up the of files, which is in the Jargon, because Jargon handles them automatically. And what may remain is we currently have some problem connect to the localhost iRODS5 server. This will help to reveal a bug of irods4j that will be fixed in the next release. As we can see, we have a link to the PR there. And the exception mapping is not finished since the implement of the exception from the irods4j is totally different from those of the Jargon. So we need more complicated implements. And the parallel upload and download could be further optimized with upload, download, pausing options by changing some parameters and handle some listeners. I also have a link that is directly to the tree that I finished all those irods4j changes. And through this whole internship, these projects, I have lots of these current key learnings. I do familiarize myself with the iRODS architecture, data flows, and also improved understanding of Java API design, which makes me to know how to develop those Java APIs, how to understand those Java APIs. And I also have improved skills in the Java input-output streams, thread pools, and chunk file transfer by writing those codes, especially upload and download things. And also learn to factor the legacy code for better maintainability and clarity. I know how to changing those old code of the Jargon into newer versions of new APIs by the irods4j. And also have improved debugging strategies for multi-thread and network-based systems. I also strengthen malware, dependency management, and build process knowledge, which is pretty essential and necessary when we are working in those projects. And I also, of course, have improved collaboration within the team when I work with other iRODS team members and have know how to do code documentation and project structure. And that's all. Thank you so much. Thank you so much for everyone who listened to my presentation.
Thanks, Ming. That's great. It really was an amazing piece of work. I'm really impressed that you were able to do all that in such a short amount of time. Our interns are here for about 3 months. The first month is really just trying to figure out what's going on, and then about a month of work, and then a month of putting a bow on it and telling a story. So this work was really done in about 4 to 5 weeks, which is pretty great. Do you have what would you say is the most kind of surprising thing that happened this summer with regards to this product? What didn't go as expected, or things that went better or worse than you expected?
I would say like my project shift from MetaLinks to Cyberduck is like pretty surprising thing. We changed the projects quickly, and I could tell it's a really good swapping. That's we don't no longer do the MetaLinks because it will take lots of time, efforts.
Yeah. That was a much bigger code base, and then we stumbled on this one and figured out this might be the right fit. That's good. Anybody else have a question?
I have a question.
Yeah, go for it.
Yeah, how did working on this project affect your view of software development?
I would say it makes me to understand how the importance is those version control, and especially how to make the code clear for everyone to use in the future. So when I write code in the future, I might in the software development, I might take more effort to make it clear, make it easier to understand for the people in the future. They might need to refactor it, they might need to understand it. And I think that is the main thing that I learned from refactoring those legacy code.
Have you ever worked on somebody else's code before? I mean, still being a student, most of the time the things you're working on are,
yes,
contrived projects or your own stuff.
Yeah, it's mostly building my own stuff. But this one, I have a chance to take a look at all this code and make me to understand why it's important to make code clear.
Excellent. Anybody else have a question?
Yeah, first off, I want to say thank you. This is actually going to be very helpful for me with the MetaLinks transition to iRODS4j. I did have one question that I've been kind of fighting with myself. There are some classes and things in Jargon that aren't really specific to well, I'll use an example. There are some utility classes, parsing paths and things like that. Did you copy any of those over in? First of all, I guess two-part question. Was this code base using any of those like Jargon utility classes? And second, did you copy any of those over into it, or like was there any Jargon code that was copied into Cyberduck?
There's no Jargon code that I copied into this project. Yeah, so I like totally. If there is some utility classes, I mostly like build them for build a new one for the irods4j and have it in this project.
Okay.
So most of the things, yeah, we don't use the Jargon code in this project.
Yeah, I think maybe Corey had to write one thing. Maybe one thing got added to irods4j, but mostly it was all in there. Okay.
That's good for me now. Thank you.
And I don't think there was anything in this code base using the zip stuff like MetaLinks does. That would be very good. Anybody else? If not, thank you, Ming. That was great. And we'll get all this merged and upstream. You'll be famous soon. Thanks a lot.